Bismillah ar-Rahman ar-Rahim. We'll continue doing these all the exams questions related to section 7.3, where we solve the differential equation, system of differential equation with constant coefficient involving real distinct eigenvalues and non-real eigenvalues. Okay, let me do this one. I have lambda equal 1 here, and lambda 1, and lambda 2 equal 2. Lambda 3 is D. He did not tell us what is it. Okay, but this is the system. Yeah, did I did it before? 1, 2 minus 1. No. Okay. So what I know to find D, I know that the trace of A, which is the sum of the diagonals, I call it the trace of A, that will be 2, is equal to lambda 1 plus lambda 2 plus lambda 3. So I have 1 plus 2 plus D is equal to 2. So D equal minus 1. So D equal minus 1. Without finding the eigenvalues, eigenvectors, do all of this calculation, we get it. Actually, it was easy also to find the eigenvalues. Now let me do the eigenvectors one by one. For lambda 1 equal 1, I let V1 to be K1, K2, K3. Okay. Let me see what will happen. I have A minus I V1. That will be what? 1 minus 1, 0, 1 minus 1, 0, 1, 0, 0, 1, minus 2, times K1, K2, K3, that equals 0, 0, 0. Is it correct? 1 minus 1, everything minus 1, the diagonal, 2 minus 1, minus 1, minus 1. Yes. So I have what are the equations? I have K2 minus K3 equals 0, K2 equals 0, K2 minus 2, K3 equals 0. So I have K2 equals 0, plug it here or there. I'm getting K3 equals 0. And K1 is the free variables, so I let K1 to be 1. So my V1 will be 1, 0, 0. So my A is 0. A is 0. Done. Now for lambda 2, which is what, 2, let V2 now. That will be K1, K2, K3. And that I have what? A minus 2I V2, which is equal to what? Yeah. 1 minus 2 minus 1, 1 minus 1, 0, 0, 0, 0, 1 minus 3 times K1, K2, K3 equals 0, 0, 0. So what I have minus K1 plus K2 minus K3 equals 0. And I have K2 minus 3, K3 equals 0. From here, I'm getting K2 equals 3, K3. Plug it here. I have what? K1 is K2 minus K3. Take K1 to the other side. I'll read it backward. K2 is 3, so that will be 2 K3. You notice I have K3 equal 1. So I let K3 equal 1. So it will be K1 is 2, and K3 and K2 equal 3. So this is 2 and this is 3. So maybe it's 3. Good. Now for lambda 3, which is we just found, which is D. D, you said it's what? Minus 1. What I have? Let V3, K1, K2, K3. So I have A plus I times V3. That will be what? Yeah, 1 minus minus 1. That will be 2, 1 minus 1, 0. 2 minus minus 1. That will be 3, 0. 0, 1, minus 1, minus minus 1, that will be 0. Times K1, K2, K3, that will be equal 0, 0, 0. So what I have 2K1 plus K2 minus K3 equals 0, and 3K2 equals 0, and K2 equals 0. Please give me K2 equals 0, plug it here. So I have K3 equals what? I have K3 is 2K1. 2K1. So I let K1 equal 1. So I have K3 equal 2. And K2 is 0. So C, that will be 2. I have K1 equal 1. I have K3 equal 2. So that plus 2. This is 2. So I have 5 minus 1, which is 4. Now, in this question, he said the general solution of the system is this. Then find all of these things. Okay. I have only lambda 3 is equal to minus 1. The rest I don't know. Okay. So I need first write the system. X prime will be 1, 1 minus 1, 0, 2, 0, 0, 1 minus 1 times x1 times x. So this is my A. To find the eigenvalues, I need what? I need 1 minus lambda, 1 minus 1, 0, 2 minus lambda, 0, 0, 1 minus 1 minus lambda. And that easily 1 minus lambda, expansion with the first column. The remaining is 2 minus lambda minus 1 minus lambda. So lambda 1 equal 1, lambda 2 equal 2, and lambda 3 equal minus 1. So this is 1, this is 2. Okay, now let me work out for lambda equal 1, lambda 1 equal 1. Solve the system. I have 0, 1 minus 1, 0, 2, 0. No, 0, 1, 0. Will not make a difference, but it's okay. 1. And this is minus 1 minus 1 minus 2 times K1, K2, K3 equals 0, 0. So what I have, K2 equals 0. So that implies K3 equals 0. So I let K1 equal 1. So V1, 1, 0, 0. So this is 1 and this is 0. This is 1 and this is 0. So the answer is 0 here. Now, for lambda 2 equal 2, what I will have? Minus 1, 1 minus 1, 0, 0, 0, 0, 1, minus 3. K1, K2, K3 equals 0, 0, 0. That implies what? From here, K2 equals 3, K3. Plug it there. So I have K1 equal K2 minus K3, which is 2K3. So I let K3 equal, oops. I let K3 equal 1. So what will happen? K1 will be 2, and K2 equals 3. Yeah, I need K3 equal 1. Yes, this is what I need. So that means V2, this is 1, which I need. K3 equal 1, K2 is 3, and this is 2. So this is 2, this is 3. So this is 2, and this is 3. Now the last one, for lambda 3 equal minus 1, what I have? Lambda 3 equal minus 1. 1 minus minus 1, that will be 2. 1 minus 1. 0, 3, 0. 0, 1, 0. Times K1, K2, K3. So that implies from these two, K2 equals 0. Plug it here. So I have K3 equals what? K3 equals from here equals 2K1. No, 2K1, this is 0 minus K3. So K3 equals 2K1. So let K1 equal 1. So K3 equal 2. So V3 will be what? 1, 0, 2. So this is 1 and this is 0. So this is 1 and this is 0. So you have 0 plus 6 plus 0. That will be 6. So this is the answer. Yeah. What will happen? This is 2 by 2. So hopefully it will be. Yeah, I think this is not with us. I will leave it. Let's repeat it. Okay. This one we did before. Yeah, so this one actually did it. Yeah, at pi over 4 minus 2, 1 e to the more pi over 4. So no need to waste time. This will be the answer. This one, I need to solve it. Yeah, that was a written question, so it's a little bit lengthy. Let me find the eigenvalues. I have determinant a minus lambda I. That will be minus 2 minus lambda 1, 3, 0, 1 minus lambda minus 4, 0, 1, 1 minus lambda. That will be minus 2 minus lambda times what? Yeah, expansion of the first column. So I have 1 minus lambda square. Let me do the calculation. That will be lambda square minus lambda minus 2 lambda plus 5 equals 0. So I have lambda 1 minus 2, easy one. And I have this one, I need to solve the equation. So I get lambda equals what? 2 plus or minus square root 4 minus 20 over 2. That is 1 plus or minus 2i. Okay. So I have alpha equal 1 and beta equal 2. So for this eigenvalue, I need to find now the solutions through cosine and sine within a real case. So now for lambda 1 plus 2i, what will happen? I have, yeah, the system will be a little bit complicated. Minus 2 minus 1 minus 2i, 1, 3, 0, 1 minus 1. So I have minus 2i, okay, and minus 4. This is 0, 1, 1 minus 1 minus 2i. That is also minus 2i times k1, k2, k3 equals 0, 0, 0. I have complicated ones. That implies what? Minus 3 minus 2i k1 plus k2 plus 3k3 is equal to 0 minus 2i k1. K2 and k3, sorry. This is k2. Okay. Now I need to find k1, k2, k3. You notice multiply the, it will be 1 minus 1 minus 2i. Okay. Minus 4. Multiply the third equation by minus 2i. That gives me what? Minus 4. So these two equations are the same. These two equations are the same equations. Notice, yeah, minus 2i times minus 2i. That will be 4i squared, which is minus 4. Okay. So from this, I can get the answers. Usually, that k2 equal 2i k3. So I plug it here to get what? Yeah, minus 3 minus 2i k1 plus 2i k3 plus 3k3 equal to 0. So you have what? Minus 3 minus 2i K1 equal minus 3 minus 2I K3. So divide by this, so K1 equal K3. Good. So I let K3 equal 1. I get what? I get K1 equal 1 and K2 equal 2I. So my V2 I start with the non-real. So my V1 V1 will be what? 1 2I1, which is 1 0 1 plus I 0 2 0. So this is B1, this is B2. So it will be my X1. X1, that will be 1 0 1 cosine 2t, okay, plus or minus 0 2 0 sine 2t, all e to the power t. And X2 is what? X2 is, where is it? Yeah, 0 2 0 cosine 2t plus 101 sine 2t 80, which is, I can rewrite it as cosine 2t minus 2 sine 2t. Okay, and cosine 2t. That is x1, 80, and this is x1. X2 will be what? Sine 2t, 2 cosine 2t, sine 2t. Yeah, 80. Now we'll do the calculation for lambda. Yeah, cosine to sine, cosine. That's a minus, I think. Sine minus 2 sine. Wait a minute. Did the mistake somewhere. A2. That will be 2I, so that 2. Okay. Two 0 to 0. Sine 2 cosine sine. Sine minus 2 cosine. Oh, there is a minus sign. Minus 2, minus 1, minus 2I. Yeah. Okay, to 2I K3. 2I K3 plus 3, that would be negative. Will be 1. Yeah. Yeah, it seems to be another solution. I think they should be correct. K1 equal K3. Yeah, we don't see mistakes there. Okay, let me do now for lambda equal minus 2. What will be the system? Minus 2 minus minus 2, that will be 0, 1, 3, 0, 3 minus 4, 0, 1, 3 times K1, K2, K3 equals 0, 0, 0. Very clear, I have only K2 plus 3K3 equals 0. 3K2 minus 4K3 equals 0. K2 plus 3K3 equals 0. Yeah, these two are the same. So these two will give me K2 equal K3 equals 0. So I let K1 to be 1. That implies V3 1, 0, 0. So my X3 will be 1, 0, 0, e to the power minus 2t. So my solution will be C1 X1 plus C2 X2 plus C3 X3. Yeah. If I do them, yeah, plus my, I think it will be the same. It will be okay. So this will be my answer. Now 2 by 2. Solve the following initial value problem. We need to do this. I have 3 minus lambda minus 2, 4 minus 1 minus lambda. That will be lambda square, lambda minus 3, lambda minus 2 lambda. Okay. Minus 3 minus plus 8 equals 0. So you have lambda square minus 2 lambda plus 5 equals 0. Yeah. Is it? Yeah. So I have lambda would be 2 plus or minus 4 minus 20 for AC. Okay, over 2. That will be 1 plus or minus 2i. Now for lambda 1 plus 2i, what I have? 3 minus 1 minus 2i. That will be 2 minus 2i minus 2. 4 minus 1 minus 1 minus 2i. So it's minus 2 minus 2i times k1, k2. That equals 0, 0. These two equations should be the same. Let me double check, then I can solve them. I have 4k1 minus 2 minus 2i k2 equals 0. Multiply the first. Yeah. Multiply by 2 plus 2i by 2. 2 plus 2i times 2 minus 2i over 2. Okay. I should get 4. Yeah. Multiply by this over 2. I should get, by 2 plus 2i by this over 2. I get this. Okay. 1 plus 2i, I get this. So multiply the first one by 1 plus 2i, you should get this, huh? Multiply by 1 plus 2, 1 plus I should get this. So 1 plus I, 2 minus 2i, that will be what? Minus 2i plus 2i gone. 2 minus 2i square plus 2 equal 4. So it's correct. So these two equations are the same. So k1 equal what? 2 plus 2i over 4 or 1 plus I over 2, k2. So I did k2, 2. K1 will be 1 plus I. So V1 will be 1 plus I2, which is 1, 2 plus 0, 2 I. Yeah. So X1 will be B1. What is B1? 1, 2 cosine beta. Beta is what? 2t minus 0, 2 sine 2t e to the power t, and X2 will be 0, 2 cosine 2t plus 1, 2, is it? Yeah, sine 2t, 80. What is the general solution? C1, X1 plus C2, X2. I think it's easy to do, easy to see. X1 is the solution of this. Find the second solution. So he gave me one eigenvalue and its eigenvectors. He wants the second eigenvalue. I know that the trace of A will be what? Minus 1 plus 7, that will be 6. And that should be equal lambda 1 plus lambda 2. This is 5. So very clear lambda 2 is equal to 1, which is agree with this one. So now for lambda 2 equal 1, what I have? Minus 1 minus 1, that will be minus 2 minus 3. And they have 4, 7 minus 1 minus 6. So I have what? Minus 2k1 minus 3k2 equals 0. Is it? This is 6 plus 6. 7 minus 1 is 6. Huh? So I have 4k1 plus 6k2. Very clear. Multiply the first equation by minus 2, I get the second equation. So I have the same equation. So from here, I'm getting what? K1 equal minus 3 over 2 K2. Let K2 equal 2. So K1 equal minus 3. So my V2 is minus 3 and 2. And my X2 is V2 A lambda 2T. And this is lambda 2. And this is V2. And that will be minus 3 to E to the power T. Yeah, I think that will do it. Yeah. The eigenvectors corresponding with eigenvalues, this, lambda 3, which is lambda 2, which is minus 5i. This is K1. This is K2. Write the general solution. So he give me most of the information. Now he wants me to rewrite it. Now from this, I have K2, because this is for the positive ones. This is what I'm looking for. 1, 1, 1 plus 5, 0, 0, I. So this is B1 and this is B2. So my first solution, K1 e to the power lambda 1t, and that EZ1 minus 146 e to the power t. X2 will be what? B1 111 cosine 5t minus 500 sine 5t. No E plus X3. Now that will be 500 cosine 5t plus 111 sine 5t. Okay. And the answer X will be C1 X1 e to the power t. Huh? Not e to the power t is part of X1. Huh? Plus C2 X2 plus C3 X3. Which is this one? Yeah. It 103. 03. These are the eigenvalues. Okay, he gave it to us. He wanted to find the eigenvectors for each one of them. Okay, so we say for lambda 1 minus 2, what will be the system? 1 minus minus, that will be 303, 030, 303 times K1, K2, K3 equals 000. So what I have K2 equals 0 from this, and I have 3K1 plus 3K3 equals 0. Is it? Then they equal minus 2. Yeah, sorry. 1 minus, that will be 3, 303, correct. Then I have 0, 3 minus minus 2, this will be 5, that will not make a difference. I have 3, 1 minus minus 2, that will be 3. So it will be 3K1 plus 3K3 is equal to 0. So this is not correct. This for lambda equal minus 2. So I have K1 equal minus K3. So V1 will be what? Minus 1, 0, 1. So there is a minus sign should be here. Or this is my answer, sorry. Yeah, this is my answer. 1, 0 minus 1 or 1, 0. I was thinking A is the correct answer. Okay, that's good. Now for lambda 2 equal to 3, what will happen? I have minus 2, 0, 3, 0, 0, 0, 3, 0, minus 2 times K1, K2, K3 equals 0, 0, 0. So I have minus 2K1 plus 3K3 equals 0. And 3K1 minus 2K3 equals 0. If we solve these two, very clear, I'm getting K2 equal K3 equals 0. So I did K1 to be 1. So I'm getting V2 1, 0, 0. Wait a minute, no, this is K1. This is K1. So I did K2. So it will be 0, 1, 0. Yeah, that will be the answer. Now for lambda 3 equal 4, what I have? Minus 3, 0, 3, 0, minus 1, 0, 3, 0, minus 3 times K1, K2, K3 equals 0, 0, 0. So I have what? K2 equals 0 and K1 equal K3. So I have V3 1, 0, 1, which is this one, and with E40. So that will be my answer. So my answer will be C1. Yeah, by the way, what is X1? X1 will be minus 1, 0, 1, E minus 2T. X2 will be 0, 1, 0, e to the power 3T. X3 will be 1, 0, 1, e to the power 4T. And that will be this. Yeah, that would be the answer. Yeah, find the general solution of this system. Let me do this one, then I will stop. I have what? 4 minus delta, r minus lambda 2 minus 3 minus 1 minus lambda. That will be lambda square, lambda minus, that will be minus 3 lambda, minus 4 plus 6 equals 0. Lambda, this is plus 2. So I have lambda minus 2, lambda minus 1. Now for lambda 1 equal 1, what we have? 3, 2, minus 3, minus 2, K1, K2. I'm doing it quickly. 3K1 plus 2K2 equals 0. So I have K1 minus 2 over 3 K3. K2, what is K3? K2. So I let K2 to be minus 3. I'm getting K1 equal 2. So V1, 2 minus 3, and X1, 2 minus 3 e to the power T. Okay, now for lambda 2, which is equal what? 2. What we have? We have 2, 2, minus 3, minus 1, minus 2, minus 3, times K1, K2 equals 0, 0. So I have 2K1 plus 2K2 equals 0, minus 3K1 minus 3K2 equals 0. Very clear, I have K1 equal minus K2. So let K2 equal minus 1, K1 will be 1. So I have V2 1 minus 1, and X2 will be 1 minus 1 e to the power what that 2T. So my capital X C1 X1 plus C2 X2. That is X1. Where is X1? That is X1. So I have this answer. Yeah. Let me stop. Then I think I need to do more videos. Let me stop the recording. Thank you.